we go. Remember that our test, Unit 1 test, well, Unit 1, there's some parts of 2. The test covering the content that we quizzed on, and the test covering the stuff we're going to cover this week will be a week from tomorrow. So we'll finish our new content this week. Monday and Tuesday we'll review, and then Wednesday we'll test. Okay? Today we're talking about exploring angle pairs. So we learned what angles are. Angles are formed with two rays, right? They share a midpoint. We measure them in degrees. We're going to learn about what we consider special angle pairs. And we recognize certain pairs of angles, especially in some criteria that we also will know about it. Sometimes it's that they're congruent, sometimes it's that we add them up, they equal a certain amount, and that will help us write equations and such to solve for variables and to find the measure maybe of missing angles. So adjacent angles. Does anybody know what the word adjacent means? What does it mean if something is adjacent? Xavier?
Like opposite side.
Sometimes it is used that way. I think I would agree with that. We're going to use a very specific definition. I would consider adjacent more as you're going to share a side. So my room is adjacent to the girls' bathroom. We know it shares a side, shares a wall, right? So much so that sometimes we can hear a toilet flush, right? So it's sharing a wall, sharing a side if we're talking about an angle. We also share a wall in Mr. Huntley's room, right? So Mr. Huntley's room on the other side is adjacent to my room. So in order for an angle to be adjacent, they have to share a side. So two coplanar angles with a common side, a common vertex, and no common interior point. So coplanar, yes. Unless they tell us differently, we're assuming coplanar. Can we see here? We're writing this stuff down the road. Common means they have the same, right? The same, they share a side, and they share the same vertex. So common side, common vertex, and they have no common interior point. Remember, interior is inside the angle, so it's in between the two rays that makes the angle can't be on the exterior or the outside. So if we're looking at these two figures, angle 1 and angle 2, do they share the side? What do you think? Kellen, are angle 1 and angle 2, do they have a side they share? Yes, they do. So angle 1, this is one side, this ray is another side. For angle 2, this ray is one side, and this other side is here. So this is the common side. So angle 1 and angle 2 are adjacent angles. The other diagram, there are two adjacent angles. How many angles in that diagram? We talked about one that looked like this several times last week. How many angles can we find in that figure on the right? Ashley? Yeah. How many angles do you see in that figure on the right? Yes, 3. So this one, ABC, right? This one, CBD, and then what's the last one, Ashley? I said ABC, CBD. What's the third one? Yeah, ABC. So basically the big one split into 2, kind of, if you think about it, or 2 stuck together, however you want to think about it. There's 3 angles there, right? 2 of the angles are adjacent angles. So angle ABC and angle CBD. adjacent angles. They share sides ray BC, or they share that side ray BC. They are adjacent angles. Now that big angle ABB is not an adjacent angle with either of these two because either one of them would include an interior point, a point that's inside of the big angle, right? The ABB is not an adjacent angle to the other two. Does that make sense? Okay. Questions on that? Okay. Vertical angles. Two angles whose sides are opposite rays. So both sides have to be opposite rays. And make sure you write that vertical angles are congruent. Remember, angles that are congruent have the same measure. Remember the word congruent, this is a symbol for that in geometry. So when lines cross, they create four angles. They create two pairs of vertical angles. So angle 2 and angle 4, if you look at those two, angle 2, this is one side, right? Angle 4, one of its sides is the opposite ray to that. So while that's a line, they don't share a side, but they have a side that's in the same line with the other angles to cross. And if you think of them as opposite angles when lines cross, the angles that are opposite from one another is also another way to help you remember. So angle 2 and angle 4 are vertical angles. And you'll see that both of their sides are that way, right? So here, this side of angle 2 and this side of angle 4 are opposite rays. They're on the same line. That makes these angles congruent because they are vertical angles, and by definition, vertical angles are congruent. So angle 2 and angle 4 are vertical angles. Angle 1 and angle 3 are also vertical angles. And I'm going to use shorthand. These little quotes mean everything is repeated underneath. So angle 1 and angle 3 are vertical angles. Remember, we mark angle that's congruent with the same number of arcs. So if they're vertical angles, then angle 2 and angle 4 are congruent. If they're vertical angles, then angle 1 and angle 3 are congruent. So if you know the measure of one, you'll know the measure of the other. There is only one line in this figure to the right. There are no vertical angles in this figure. There are no vertical angles here. No vertical angles. So angle 5 and angle 7, you might be tempted to think they're opposite angles, but if you extend the side of angle 5 and the side of angle 7, they're not vertical angles, okay? Any questions on vertical angles? Everybody knows what this symbol means? Okay. Complementary and supplementary angles. You guys remember what this means from middle school? Charlie? I don't know, look like you're raising your hand too. Oh, okay. Anybody remember what complementary and supplementary, anything about complementary and supplementary argument? So you're close. What do you mean when you say complementary is 90 and supplementary is 180? Well, 90 degrees is the right angle, right? So you vaguely, you've been taught it before, right? So you're remembering something that's not quite all the parts. So we're talking about pairs of angles. So angles, complementary angles. So two angles, if you add them up, you equal 90 degrees. Supplementary angles, two angles that if you add them up, they equal 180 degrees. So she remembered part of it at least. So she knew that she had learned it before. So we're reviewing that. Complementary angles are two angles. These measures have a sum of 90 degrees, and each is the complement of the other. So how do we know that angle 1 and angle 2 have a sum of 90 degrees? Remember, don't forget, this little box here tells me that this is a right angle. And we have to know that a right angle is 90 degrees, right? So that little box, sometimes that box is even filled in. So a right angle is indicated by that box. And we have to know that a right angle is exactly 90 degrees. So angle 1 and angle 2 together, you add them together, they equal that bigger angle, which is a right angle. So now that we know that angle 1 and angle 2 are complements of one another. They are complementary angles. They do not have to be adjacent. So angles 1 and angle 2, they share a side, right? They share this ray as one of the sides of their angles. They don't have to share a side. It's okay. 60 plus 30 equals 90 degrees. That makes angle A and angle B complementary to one another. Sandra, you got these two things written? The supplementary angle. Two angles whose measures have a sum of 180 degrees. Each angle is considered the supplement of the other. You're having a hard time remembering which is which. I remember it because C for complementary comes earlier in the alphabet, and 90 degrees comes earlier on the number line, right? S comes later in the alphabet, and 180 degrees comes later on the number line. We learned about straight angles, which we call lines. How many degrees does a line have? 180, right? It is technically a straight angle. We call them lines. We have to know that lines have a measure of 180 degrees. So we're looking at this line here. So this line could be considered as two opposite rays, right? So this ray is the side of angle 3. This ray, opposite ray, is the side of angle 4. They share this side, right? Together, because they're opposite, the non-shared sides are aligned, now we have to know that they equal 180 degrees. So angle 3 plus angle 4 equals 180 degrees. They do not have to share a side to be considered supplementary, just like they don't have to share a side to be considered complementary. So there's 120 degrees plus 60 equals 180. That makes those supplementary. They do not have to be adjacent. And maybe circle or an asterisk or something by this on your notes. Complementary and supplementary does not say anything about where the angles are located, and that just means kind of what I just told you. They don't have to be adjacent, right? They don't have to be adjacent. They don't have to be in the same plane, I would presume. If you take the measure of the angles and add them together, they're 180 for supplementary. Take the measure of the angle and add them together, they're 90 for complementary. Any questions on these two? Okay. A linear pair. A linear pair is basically a special kind of supplementary angle. The linear pair is a supplementary angle, but its pair of angles have to be adjacent. They have to be adjacent. A pair of adjacent angles. So when it comes to linear pair, location does matter. They do have to have a side that they share. So they are also supplementary. Because one of the pairs of sides forms a line. So, for example, this is an adjacent pair of angles whose non-shared sides form a straight angle, which we really call a line, right? So the straight angle is just a line. So angle PQR and angle RQS are a linear pair. Which means that angle PQR plus angle RQS equals 180 degrees, because we said they are supplementary. There is no linear pair in this diagram. There's no linear pair here. It has to have a line. Once a pair of the unshared sides have to form a line. So there's no linear pair because there has to be a line for there to be a linear pair. There's a ray here, a ray here, a ray here. But these rays are not opposite rays, right? They would have to be a straight angle to be opposite rays and to be a line. So there's no linear pair here. Any questions on that? Okay. Bisector, an angle bisector. So we learned about a segment bisector. What do you know about a segment bisector, Daria? What do you know about a segment bisector? Devanshi, what do you know about a segment bisector? Okay, well, let's look at the word bisector. What's the prefix bi mean to? What do you think the that root word, the other part, sector, might mean? What do you, sections? You know, you said sections. Makes sense, right? So two sections, bisector. So an angle that is split into two sections. Now they have to be congruent sections, right? So two congruent angles. So if you have a ray that divides another angle into two congruent angles, then that ray is a segment bisector. So it has to be congruent. So like our midpoint is a segment bisector. A midpoint is the point that's equidistant from either endpoint. It can't just be in between. It's got to be exactly in the middle. So the distance from the middle point, from that midpoint to the left endpoint, midpoint to the right endpoint, has to be the same distance. An angle bisector, so here, angle ABD is a big angle, right? We know that angle BC is an angle bisector because this tells us that angle ABC and angle CBD, which make up that angle, that bigger angle, are the same measure. So they're congruent. So ray BC is the angle bisector. And we know that because of this mark here. We know that angle ABC is congruent to angle CBD. So by definition, a ray that divides an angle into two congruent angles is an angle bisector. And that endpoint is at the angle vertex. So the endpoint of that ray will always be the same as the vertex. Just like the input of all the sides in those angles have to be the same as well. Remember that little squiggly thing means congruent. Get used to recognizing what that means. Congruent means the same measure. So if it's a segment, it's the same length. If it's an angle, it's the same number of degrees. Sports, it's not like that. Yeah, I'm redoing that one. It won't write from back there very neatly, so I'm going to come over here a little closer. Usually does a better job over here. So this symbol means congruent. Congruent means same measure. So we have 4 examples. We're going to pop through them pretty quickly because we get out of here at 52. So we got about 9 or 10 minutes to get our 4 examples in, which we can do. All right, they're kind of squished in here, so let's go ahead and label them as example 1, example 2, example 3, and example 4. It says find X. In example 2's case, we're actually going to find Y. But we're solving for the variable, okay? Here we are given the measure of one of the angles, but we're giving expressions that represent the measure of angles, and we have to use our new terminology that we learned to be able to write the equations for these angles. So, what kind of angles do you think angle ABE and angle EBC are, Xavier?
They're linear pairs.
They are linear pairs. What did we learn about linear pairs?
Linear pairs. They are supplements.
Yes, they're supplements of one another. So angle ABE and angle EBC are a linear pair, which means that together they add up to 180. So I'm going to write example 1 down here. So 2x plus 4 plus 4x plus 36 has to equal 180. So now I'm combining my like terms on each side, and I have 6x plus 40. Okay, did I write everything correctly? Just checking my 2x plus 4 equals 180. We're going to subtract 40 from both sides, and 6x equals 140. And we're going to divide both sides by 6. I don't think that's right. Oh, 24. So I left something out. See why Ms. Zimmerman says to use pencil? And if you don't make a mistake, I am likely to on occasion. Thank you. I did not remember that being a mixed number. All right, so let's fix that. 24 and 36, I believe, is 60. So, you guys checking my math there? 24 plus 36 is 60. Okay, so now we have 6x. We subtract 60 from both sides, and 6x equals 120. Divide both sides by 6, and x equals 20. So that's how we set up the equation for that first example. All right, what do we know about the angles in the second example? 7y minus 1 and 55. What's the only thing we know about those two angles? Sam? What do we know about these two angles? GFL and LFH. What do these arcs tell us, Sion? They're congruent. So that means we can write the equation setting them equal to one another. So for number 2, 2y minus 1 equals 55. They have to be the same measure because they're marked the same number of little arcs. Add 1 to both sides. We know that 2y equals, not 2y, I can't read my own handwriting, is it 7y?
Yeah.
Thank you, guys. 7y equals 56. Getting into too big of a hurry. Divide both sides by 7, and y equals 8. Let's look at example 3. Same thing, we know that these two angles are congruent to one another. So we're going to set them equal to one another in an equation, and then we're going to solve for x. We don't know if they equal 90. We don't know that they equal 180. We just know that they have the same measure. So example 3, we know that 3x plus 32 equals 9x minus 4. So we have to remember in this case, our first step is to get our variables on the same side. We're going to subtract 3x from both sides. 32 equals 6x minus 4. We're going to add 4 to both sides. 36 equals 6x. And now we're going to divide both sides by 6, because that's what's happening to the variable last but not least. And now we know that x, for example 3, is 6. Any questions on that one? Number 2 is 8. Right there. You're welcome. Last but not least, now example number 4. What do we know? Can anybody write the equation for that one for me? You think you could write the equation for that one, Thomas? No. Is it marked as congruent, Thomas? Good try, though. Right. What do we know? This is a line, right? So that makes these two angles what kind of pair? A line, root word of linear is line, right? So it makes them a linear pair. How many degrees are in an angle, or in a line, Thomas?
180.
Yes, so linear pairs always add up to 180. So these, because their non-shared side forms a line, anytime you see two angles, that the other side, the extra sides or the non-shared sides form a line, we should be thinking linear pair. So for example, 4, our equation is going to be one angle plus the other angle equals 180. So we're going to combine our like terms here. 100 minus 10 is 90 plus 9x equals 180. We're going to subtract 90 from both sides. And 9x equals 90. We're going to divide both sides by 9. And now we know that in example 4, x equals 10. If you wanted to find the measure of one of those angles, just plug the value of that variable in the expression that represents the measure of that angle. You can scan and submit them now before you pass them away. We've got just a couple minutes before the bell rings. Remember, the worksheet is due tomorrow at 7 a.m. So be scanned and submitted by 7 a.m. unless you have an accommodation for time, and then you have until Thursday morning at 7 a.m.